Hello everybody, so this is going back and reviewing the Pythagorean theorem. You guys need this to be able to do some of the trig and also some practice on reducing radicals. So here goes. You know that the Pythagorean theorem is a squared plus b squared is c squared. Which one is a and b makes no difference because they're the side. It's the side of the triangle squared plus a different side of the triangle squared is the hypotenuse squared. C is always the hypotenuse. Okay? So in this particular case, you're missing the hypotenuse, so that's C. Which one is A, which one is B, so what? Because 7 squared plus 24 squared is exactly the same thing as 24 squared plus 7 squared. Adding is commutative. You can change their order. So it doesn't matter who's A or who's B. Okay? Equals C squared. Okay, so you grab your handy-dandy calculator, and you go 24 squared plus 7 squared, 24 squared plus 7 squared equals 625 is c squared. You want to get rid of the square and the c, so you square root both sides, and then you type that in your calculator, and hopefully everything turns out well, and it comes out nice and perfect. If it comes out a decimal, then there's work involved. 25. So 25 is equal to C. Life is good. Done. Okay? So let's go here. This is the hypotenuse. This is C. This, it doesn't matter which one is A, which one's B. How about I let this be A and this be B? So A squared plus B squared is equal to C squared. I'm saying A is 4. B, I don't know, equals C squared, which is 12 squared. You want to solve for b, so this 4 has to go to the other side. So I'm going to subtract the 4 squared from both sides. So now I've got b squared is equal to 12 squared minus 4 squared. I want to get rid of this square, so I'm going to square root both sides. b is equal to the square root of 12 squared minus 4 squared. And y'all that are tempted to do this, squares undo square roots and cancel them, you can't. It doesn't work that way. If it's a product, you can cancel the squares and the square root. But when you're adding or subtracting, you can't cancel the root. It doesn't work. It just doesn't. Okay, I'm going to prove it to you. 2 squared minus, well, I can't do it that way. Your calculator won't function that way. 3 squared minus 2 squared. You know that that's 9 minus 4, so that's 5. So it's the square root of 5. If you cancel this, you go 3 minus 2, which is 1. Now let's type the original statement in the calculator. So square root, and it was 3 squared minus 2 squared. And once I hit enter, if it's a 1, then I'm lying. If it's some funky decimal, then I'm telling you the truth. Funky decimal. Okay? You cannot cancel squares and square roots when you're adding and subtracting. So what do? Just type in your calculator. And if it comes out funky, then we know what to do. But I'm just going to do the work inside. 12 squared minus 4 squared. Whoops. I hit 11. 12 squared minus 4 squared is 105. So b is equal to the square root of 105. Now, this isn't a perfect square. I mean, I'll prove it. Square root 105. Whoops, come on. 105. Good. Okay. So what we have to do is we have to break this down and see what if we can pull anything out. We have to simplify the root. So I'm going to first divide it by 5. 5 goes into 105. So 105 divided by 5 gives me 21. And 21 is made up of 3 and 7. So this is made up of 3 times 5 times 7. None of that is popping out of the root, meaning none of them are squares. It's not like you had 4 times 11. Then if it's in a square root, then you got square root of 4, square root of 11, so you got 2 square roots of 11. That's not happening. So the square root of 105 is your final answer. Okay? It doesn't simplify. All right. Let's try this one. I need to find the missing side. Previously I said this was A, this was B. Let's switch it up. Let's say this is B and this is A. It's not going to matter as long as that's the hypotenuse. Okay? So A squared plus 2 squared is equal to the square root of 58 squared. This cancels out. So you got A squared plus 4 is equal to 58. I can subtract the 4. So A squared is equal to 54. Now square root both sides. A is equal to the square root of 54. Now that, I know you can simplify. That is what 9 times 6 is 54. So that's square root of 9 times the square root of 6, or 3 square root of 6. That's your answer. Okay? All right. A, B, C. So 1 squared plus the square root of 31 squared is equal to C squared. 1 plus, those cancel out, 31 is equal to C squared. So 32 is equal to C squared. Square root both sides. Square root of 32 is equal to C. That is 16 times 2. So that's the square root of 16 times the square root of 2, which is 4 square roots of 2. It's C. Okay. How about that's A, that's B? So 3 squared plus B squared is equal to, that's C, 5 squared. Subtract the 3 squared off. B squared is equal to 5 squared minus 3 squared. B squared is equal to 25 minus 9. B squared is equal to 16. Square root both sides. B is equal to 4. Okay, I think that's the last one. Yep. Thanks for your time. Have yourself a great one.